Hey guys, today we're going to be showing you a single displacement reaction between zinc and hydrochloric acid.
So the first thing we're going to do is we're going to grab our Erlenmeyer flask from the container section and place it on our workbench. And then we're going to add hydrochloric acid to the Erlenmeyer flask. Now this hydrochloric acid has a molarity of 6, which is the equivalent of 6 moles per liter. But we're going to add 15 milliliters to the Erlenmeyer flask.
At this point, we're going to double click on the flask and close it so that later in the experiment when it's producing gas, the gas does not escape.
And now the next step will be to add a thermometer from the instrument section. Thermometer will gauge the temperature of the contents of the Erlenmeyer flask. So you can see now we have 21.5 degrees Celsius. And now we're going to add a pressure gauge as well. So we can now see that the pressure gauge show 1 atmosphere. Yeah, so we're at room temperature and pressure here.
Alright guys, at this point we're going to start the reaction by adding in zinc into the hydrochloric acid. The program itself will put in the zinc and immediately close the flask right after so there's nothing lost in the gas. And we're going to be adding 0.25 grams of this zinc into the flask. You can also add 25, but we're just going to be adding 0.25 for now.
So now as soon as the zinc gets added, you can see that the temperature rose to 26.5 degrees Celsius and the atmosphere also rose to 1.71 atmospheres.
So this is currently dropping, and we're going to be waiting for this to drop back to room temperature. And you can notice that the atmosphere is dropping with the temperature. So as the temperature drops, there's less movement in the beaker gas-wise, and that lowers pressure inside the flask.
And so now we're going to be looking at the chemical reaction. So you can see we have 2 moles of aqueous solution of hydrochloric acid reacting with 2 moles of solid zinc on the reactant side. And then on the product side, we have hydrogen gas and 2 moles of aqueous solution of zinc chloride. So that is our chemical reaction taking place.
Alright guys, we're still waiting for this to drop back down to room temperature.
As soon as it gets within half a degree of 21.5 degrees Celsius, we are going to be sticking a syringe into the Erlenmeyer flask. And what that will do is that will allow us to see the hydrogen gas gather up. And if you remember, the hydrogen gas is one of the products of our chemical reaction. So we can actually see that the pressure is building up. So yeah, the temperature and pressure within the Erlenmeyer flask itself right now is slowly dropping. We saw that the atmosphere got to a total of 1.71. It is now 1.69. And the temperature at one point was 26.4 degrees, I believe. Now it is 22.4.
So you can see now that 0.1 milliliters of the hydrochloric acid reacted with the zinc. So that was the reaction that happened.
And we're getting ready to stick the syringe into the Erlenmeyer flask as soon as we get to 22 degrees Celsius. So, and we can stick it in right now. Yes, there we go. And so now we can see that if you scroll your mouse over the syringe, there's 92.6 milliliters. That's the volume in there right now. So that's the hydrogen gas from our chemical reaction.
You can record this observation, and at this